So, good evening, everyone who joined tonight for the Royal Meteorological Society History Group first virtual meeting this season, I suppose, which is featuring Professor Jim Fleming from Colby College in Maine. With his talk, "Everything is Unprecedented If You Don't Study History." It's an intriguing title. I hope that you will enjoy immensely. My name is Vladimir Jankovic. I'm a chair of history group of the RMETS, and I want to say a couple of things before we introduce Jim's talk tonight. So I want to welcome everyone to this first virtual meeting of the group, which has a full name of History of Meteorology and Physical Oceanography Special Interest Group, founded in 1983, and is one of the longest running special interest groups of the Society, and we're very proud of that. The group runs a wide variety of events, meetings, some independently and some jointly with RMETS and other external partners. The group also publishes a newsletter with articles, news items, historical details, and short features. It also publishes the occasional papers for more detailed research studies. So far, we had 20 volumes of occasional papers. If you wish to be part of History Group, you can join our membership list. This membership is free. You have the benefits of having the first view of the newsletter and the information about upcoming events and meetings. For more information, you can click, probably not now, but here is a link for you to join the group. All the inquiries can go to history@rmets.org. If you're not a member of the Royal Meteorological Society yet, and you have interest, please join. Anyone who's interested or has been involved in meteorology and climate change and oceanography can join our historic and world-leading society. We are made up of professionals, enthusiasts, academics, students, and teachers. The benefits include the list up here, which is the access to weather magazine on your smartphone, online, so on. Discounts at all the conferences and paid for meetings. Discounts in our 6 other journals, including the new online journal, Climate Resilience and Sustainability, and access to support grants and discounts in our RMETS shop. Here is a club, used to be the Weather Club, with a new name, Met Matters, which is the enthusiast blog for all things weather and climate. So please sign up to the Met Matters newsletter, and then you can enjoy, again, the things that are listed on this slide, which is a monthly newsletter, the information about events, opportunities to participate in the Citizen Science Project, and to hear from the experts who are featured on the blog, and so on and so forth. So I'll probably move to the final information before I introduce our speaker tonight, and that is that if you wish to ask a question tonight, please use the chat area, which is to the right of your screen. And if you wish to ask the question, probably a good idea is to ask the question as soon as you can think of one during the Jim's talk, rather than to wait for the end. That way we can have a proper sequence of questions to ask immediately after the talk. So please do so. I'd like to ask you that all the questions be relevant to the presentation, very closely linked to that. And I also want to warn you that depending on the numbers, that might be not enough time to answer all of them in the time we're left after the talk itself. The talk we're hoping to finish roughly around 9 o'clock British time, which I don't know what time it is currently in the US where Jim is calling, and that's pretty much what I wanted to say now. So I'd like to say a couple of things about our speaker today, and it's my distinct pleasure to introduce our speaker, who's my colleague and dear friend, Jim Fleming, a historian of science and technology, and Charles A. Dana, professor of science technology studies at Colby College, and he's also research associate at the Smithsonian Institution. Jim has earned degrees in astronomy from Penn State, atmospheric science from Colorado State, and history from Princeton. His teaching connects the sciences and the humanities, and his research interests involve the history of geophysical science, especially meteorology and climate change. His books include Meteorology in America, Historical Perspectives on Climate Change, The Callendar Effect, Fixing the Sky, The History of Geoengineering, Inventing Atmospheric Sciences, and the latest, First Woman, Joanne Simpson, and The Tropical Atmosphere, recently published. For generations of students and historians who read and built on his work, Jim was not simply a model academic and a source of intellectual inspiration. He was also a force that pushed the boundaries, in my view, what can be known and imagined about weather, climate, and atmospheric sciences. He was also someone who shared his ideas generously. When in 2001, he founded the International Commission on the History of Meteorology, he chose the motto to be scholarship and friendship, the motto that remains to this day and testifies to Jim's enthusiasm for both the quest for knowledge and the people who joined him in that quest. Throughout his career, Jim ran research projects, received major awards, published landmark books on the history of atmospheric sciences, organized congresses, and nurtured generations of students, but also, in a genuine spirit of sharing his knowledge, invited many colleagues to the unique place that is Colby College, where some of us had a chance to see his love for all things atmospheric in action. In my view, Jim has defined the field of history of meteorology and climatology, not only through his publications, but also through his gift, which I hope you will witness tonight, to communicate scientific matters in a way that matters to both scholars and general public. The title of his talk today is Signature to his achievement, but also it's a signature to the achievement of the field he has helped create over the last 3 decades. Everything is unprecedented if you don't study history. So with that, I'd like to introduce Professor James Roger Fleming from Colby College to join us tonight in a virtual meeting. Jim, please.
Thank you so much. And greetings to the assembled group. It's really a pleasure to be with you and to receive this really a challenging invitation from Vladimir, not to talk about my latest book, which I could do probably in my sleep, but to talk about some more synthetic issues that allow me to look back at my career. I'll be a little self-indulgent, if you forgive me. A little bit about me, but possibly too much about all the things that I've been thinking and working about. I'll try to go through quickly, and I left the bibliography if you'd like to follow up on any of these things in your library or bookstore. You can click on that under the handouts tab on the right-hand side. And so I did bring, we have a technology difference here. I'm going to be using my Adobe PowerPoint slides tonight. So I'll be leaving the screen pretty shortly. But I did bring copies of the books with me. If you'd like to read any of them, you can get the list off the web server. Historical Perspectives, The British Steam Engineer, Guy Callendar, who established the anthropogenic greenhouse effect. This was really a labor of love too. Also the DVD that comes from the University of East Anglia papers. There's a digital copy of Callendar's papers. And only 3 more to go. The Fixing the Sky book, which is about climate engineers. I'll talk about each one a little bit in this talk. Inventing Atmospheric Science, which takes a look at the 20th century, at least up through 1960, and asks the question, where do we go from here? And then the book this last October that Vladimir mentioned on Joanne Simpson and the tropical atmosphere. So I just realized I won't be able to have my face on the screen. It might be a benefit to many of the people in the audience, but I will be able to show some slides now and talk about a pathway into the field, which for me was through science and then history, and why I think this history matters so much in trying to understand our beloved atmosphere. Let me go to screen sharing, and I'll start a little slideshow. Maybe that's the wrong button. Eleanor, is it the wrong button? Okay. Okay, is this going well? Do you see a slide with the atmosphere and all its complexity on it? Okay, good. There is my email. If you'd like to write to me, I would be happy to write back if you don't get your question in the queue or if you had any other questions afterwards. It was several years ago. I was working on the book called Fixing the Sky, and I went to a geoengineering meeting, 2006 actually, and a lot of the speakers were claiming that everything was unprecedented and that we had to respond in a sort of a knee-jerk emergency mode to the climate problem through climate intervention. And I didn't hear any reference to history. And so having just finished, or recently finished this study, I said to the group, I said, history matters. And this became the motto and the epigraph for the book. And so I'm going to talk about my personal pathway and then some professional reflections on bringing together the fields of atmospheric science and the history of science. This is a slide that indicates the tropical cirrus clouds that often form as outblow from the hot towers, the giant cumulonimbus clouds. And my venture into atmospheric science started by my master's degree, where I studied the radiative effects of cirrus clouds. And I built a cloud model that allowed the sunlight to come through and the infrared radiation to interact with the ice crystals. And that study remains in print and was my introduction to the atmosphere. I'd come out of astronomy and was not very keen on forecasting, but I was keen on the atmospheric radiative transfer issues. I was able to work at the National Center for Atmospheric Research in Boulder, Colorado, and there they assigned me to a glider project. So I flew in the NCAR glider along the Continental Divide in Colorado, and we went into clouds, flew up through the clouds that were budding cumulus congestus, and tried to get out of there before they turned into cumulonimbus. This was a very exciting thing to do as a young man, and it was also very exhilarating. It was very. I don't think it was too dangerous because I really trusted my pilot, but I do know that I couldn't eat very much. I had to orient myself and keep the glider on track as we collected cloud particles. We would fly into the cloud, circle around for up to an hour in total whiteout, and then pop out the top, and suddenly your focus would go from zero distance to infinity as we came out on top of the Rocky Mountains. It was really quite exhilarating. That project, unfortunately, was canceled when some locals who thought we were cloud seeding decided they would throw a Molotov cocktail into the glider hangar, and they burned up the wing of the Enclair glider. And one of my saddest moments was seeing that glider be cranked onto a flatbed truck and taken back to Boulder, Colorado at the end of the project. So I was involved in atmospheric science at the master's degree level and working on observational programs and projects where I had high altitude clearance and training. I also worked at the University of Washington, where they had a surplus World War II B-23 bomber that had never seen action, but it was a surplus bomber. And underneath the airplane, we had particle collectors that were gathering hydrometeors and also looking at some traces of silver iodide. As other people were cloud seeding, we were tracing their plumes for the University of Washington. The reason I left atmospheric science, number one, I thought that about 6,000 other people could do the same kind of scientific work I was doing. It wasn't that high level, and I wasn't that astute at it. But secondly, this bomber almost crashed, and we came down into the regional airport on one stormy night. We had been flying all night on a Pacific storm, and at the very end of the flight, when our fuel was low, we went to very high altitude to collect cirrus crystals. And I asked the PI, I said, why do we go all the way up there when we're already tired and sick? And he said, oh, because the Air Force is paying us to collect ice crystals in a study to see if their missile nose cones could survive reentry through a cirrus shield. And that kind of disturbed me. That was back in the 70s, and I wasn't quite too excited about working on a military contract. But coming down that night, and very turbulent after effect of the storm, we came into the regional airport, which was surrounded by trees. And I looked out the left and the right sides of the airplane and got on the microphone and the intercom, and I said, brace for impact, because the trees were right at our eye level. And we did end up cutting off the top of a pine tree with our instrument package. Another meter or two lower, we might have tipped the plane and crashed the whole outfit. But I remember pulling the pine branch out of the particle collector. It was my duty to take care of the instruments. And I thought right then and there, I have to find some other way to engage with the atmosphere. And that longer term engagement was not on a flight crew, but was with studying its history, which allowed me to have a little bit safer environment and a longer term to think about these things. So I left the University of Washington and retooled as a professional historian through my PhD work at Princeton University. And the one thing I learned in the atmosphere is that, and this will come back when I talk about the tropical atmosphere especially, is that the atmosphere is stable, basically, except when it isn't. And these up and down arrows indicate that a lot of subsidence is happening. There's clear spaces for every cloud. There's high pressure areas for every low pressure area. And there's a balance here. But the violence of the atmosphere is usually highly condensed into things like thunderstorms, tornadoes, hurricanes. And those are the ones that are difficult to forecast. The clear blue sky persistence forecast is really quite straightforward. And so this applies big time to the tropical atmosphere. We'll get to that in a few minutes. Now the books. I already waved this one around. This was my dissertation study that turned into a book from the Johns Hopkins University Press. And somebody asked me once, what is this book about? It's about its history of science in a certain time period. And I simply replied quickly. I said, the book is about America. It's a vehicle through which you can understand the Western expansion of networks and systems. It's a way to understand meteorology before there was a National Weather Service. It's a way to understand a pre-disciplinary period when there wasn't any societies or journals specialized at all. And it was a very interesting study of what was called the problem of American storms, where James Espy and William Redfield were fighting about what kind of wind patterns you would find in storms. and Robert Hare had his own opinions about that. And so it was a period from about 1800 to about 1870 where this new technology of telegraphy came in, and the new phenomena of futures markets in some of the cotton and orange juice and hog bellies and things like that. It was a story of Western expansion and the expansion of the American frontier, not through cowboys, but through the expansion of observers going out as far as San Francisco. And these were volunteers organized by the Smithsonian Institution, and then eventually entrained into federal service, where the U.S. Army Signal Office began the National Weather Service. There's a cartoon at the bottom, which is kind of a fun one, because you see the Native Americans discussing these folks putting up a telegraph pole. And there's little weather instruments on the top of the shed. There's some buffalo in the background. And the caption says, Signals Bureau, Introduction of Science to the Far West. There's incredibly interesting stories there about the interaction of the cultures of the Native Americans and the Western settlers, and bringing telegraph lines, not just everywhere, but into places like Sioux Indian country and Apache country in the southwest of the U.S. So the Signal Service was nominally interested in storms, but they were mostly interested in national security. And this became an information system run through the telegraph that was really worried about storms and strikes and Native American uprising. So the period was really quite interesting, quite formative, and led to this Hopkins publication that I guess it really helped me get my job. That's all I'm going to say about it. But there's a lot more to the stories about Joseph Henry and Matthew Maury and William Farrell, things like that. I then decided that I couldn't just continue on into the later era, but I wanted to look at a bigger picture. Climate change was really heating up as a discussion circa 1990s, and I was able to look at the historical perspectives by a series of connected essays. I realized that it wasn't just about the studies, it wasn't just about the publications, and I spent about a year on sabbatical in 1993, just looking for a metaphor to organize all of my files. I was collecting a file cabinet full of articles and chapters, and I remember marking the drawers in the file cabinet. I put a little Post-it note on. One was called A1, one was called A2, and the third was called A3. I think the fourth drawer was just full of junk. But A1 was apprehension of, in the sense of gradual awareness and understanding of climate. The climate is not something you can just point at and say, there it is, or look at the climate over there, not like a star that's coming across the meridian for an astronomer. The climate requires some sort of other ways of networks of observation, perhaps, some insights into physical law, some connections with the social fabric. And so the first A1 was awareness and understanding, which was dawning. It wasn't sudden. It wasn't completely clear. We were dimly perceiving climate and looking for things like climate change in the period of about 1800 to 1900. Or this book goes on into the 1990s. But I also realized it wasn't about America. It was about ways that the European message had come to America, ways that Americans had gone to Europe. And suddenly I'm getting involved with European theorists, European studies, and it became more of for me, it was a transatlantic study that looked at climate across the Atlantic. A2, the drawer A2, was another realization that one of the definitions of apprehension is about fear. And so this climates of fear, worries about the return of the glaciers, volcanic weather, crop failure, things that eventually turn into the kinds of air pollution and global warming of the 20th century. And so, as the geographer Yifu Tuan once said, to apprehend is to risk apprehension. To understand something is to ask yourself, well, why am I concerned about that something now? That's one of Immanuel Kant's big questions. And so A2 was all about the ways that people feared the change of their climate, the change of their livelihood, the change of their agriculture. And that's written into even the change of their livelihoods, their change of their well-being as people moved into other areas of the world, because climate change used to mean moving to another area. Colonization was a big risk because you would be exposing yourself and perhaps your descendants to a new climate, new airs, new waters, and new places. Straw A3 was about intervention and control, because if you are speeding down the highway, you might get apprehended by the gendarme. And that is another theme that came up in the book, is about if the climate is changing, or if it's changing beyond reasonable limits, what can we do? What shall we do? How could we intervene? And so the book unfolds with lots of protagonists, lots of chapters. It was almost a collected series of essays about early authority, early prestige, the collection of data by expanding networks, the new experiments of people like John Tyndall there on the bottom of the screen, the models that people put together. I have Svante Arrhenius there symbolizing that. And then new technologies to make the atmosphere a much bigger term than it was back in the early 19th century. It became much more than surface weather. It became more global. And then in the late 20th century, the coming of groups like the Intergovernmental Panel on Climate Change, and a group aiming for consensus. I couldn't resist a little cartoon in the bottom right. I'm not interacting with you as an audience. I can't see you, but these were cartoons from 1953 by the famous cartoonist Virgil Partch, and he had migrating species responding to climate change. And he called it the North Express, as the palm trees and the agave pull up roots and move north if the climate gets too hot. There's a whole collection of these I have, and I started looking for visual evidence and visual ways to portray climate change. I think that based on the theme of the talk, that everything's unprecedented. There was a very powerful scientific group in the U.S. Global Change Research Program here about 1998, and they were regaling me about how their imprimatur to do their study went all the way back to 1990 when they were formed. And I said, well, my studies go at least back to 1790 when Thomas Jefferson said, make a survey of the American climate. So this federally funded group got really excited that they could extend their own prehistory by 200 years, and began using my perspectives to show that climate change was daunting, but it was not at all new. That early colonists and European Enlightenment philosophers had thought a lot about climate change over the years. So that was kind of fun. And I'll move on to the Callendar Effect. This is our guy, Callendar, British steam engineer who lived in Ealing and eventually in Sussex, and worked in the British petroleum industry. In World War II, he built the burner system around airports that allowed the fog to be lifted. It was called FIDO, Fog Intensive Dispersal of, I think is the acronym. And he was a steam engineer who knew the combustion natures of fuels, and was able to study the molecules generated by combustion. And so he brought us what we call the Callendar Effect. Actually, this term is it's a way of saying anthropogenic greenhouse effect, human-caused influence on climate. And Roger Revelle from Scripps Institution of Oceanography actually called it the Callendar Effect at least once. So this became, again, a labor of love to look at his theory of climate change brought about by anthropogenic increases in the concentration of atmospheric CO2 primarily through the process of combustion. And his key paper, beginning that long series of publications, was done in 1938. He was also concerned about deforestation. And he actually, I think I'll tell this group now, he tried to write a book in retirement just called, I think, Carbon Dioxide and Climate. I have the illustrations from the book in his papers, but I don't have the manuscript. And Gordon Manley might have got a hold of it, or there might be other, Derek Shove. There were people who could have helped to edit this manuscript, and it went missing. So I would be delighted if anybody knows where about a 200 or 300 page document resides, typescript on Callendar's retirement work. His papers were getting scattered around the University of East Anglia, and I recruited my son. This is my son Jason, a number of years ago, maybe 2 decades almost, organizing the notebooks. And you can see a table full of notebooks. He kept extensive notes on world temperatures, on fossil fuel consumption, on carbon dioxide concentrations as best he could identify them, and then on infrared radiation, which was expanding to include all the different bandwidths of the various atmospheric gases. Putting those 4 things together allowed him to write these papers warning about climate change, which in his life, and this is true for others like Arrhenius, it wasn't necessarily a bad thing. It was a warming that might increase agriculture, that might increase the greenhouse effect was not that well defined, but he really contributed the understanding of the human dimension of it. So everybody's always been looking for the so-called ancestor or father or grandfather of the greenhouse effect. And I think a lot of people need to take credit for that, or can be given credit for that. And I think Callendar is one of the key people in that lineage. This picture of Callendar came from his daughter, Phyllis Kahn in North London. And we traced it down to the family papers, and she generously gave us access to this. There was never a picture of Callendar in the public in the record until we got a hold of this handsome portrait of Guy heading off to the U.S. Steam conference. I think the bigger picture is on a steamship coming to America to study the steam tables that he was contributing to with his father. So this was really, truly a labor of love. I've stayed in touch with Phyllis and her husband, Munimar, over the years. And it was a foray into the 20th century for me. I'd mostly worked in the 18th and 19th centuries, and now I was moving into the 20th. Fixing the Sky, again, that was a really fun book because it came up just as the geoengineers were starting to talk about intervention, and that's where the epigraph and the title of the talk came from. But it was about the quest to control nature. It's about hubris, really. It's about overreaching, about reaching to the sky, but falling short of having a real technique or technology, or even wisdom enough to control nature. And this includes a long history. So the people talking about climate intervention in 2006 at the kind of a first meeting that I'm aware of at the NASA Ames campus of Mountain View, California, these people were claiming that nothing like this had ever been seen before. And I was able to provide a history of that, which allowed for a longer baseline of reflection that many, many people had thought about this with many techniques. And most of the techniques were based on the latest technology. When there was extensive cannonading in the Civil War, U.S. Civil War, there was almost a certainty that the cannon fire had caused the clouds to precipitate. And as proof of that, they showed that it tended to rain right after battles. As a counter to that, it's pretty clear that the generals would only fight when the weather was pretty nice, and after about a 7-day period, there would typically be rain anyway. So that ancient theory of that rain follows the battle as kind of a cleansing from the skies was was very active in the 1860s. James Espy, who was involved in the earlier storm controversy, used his convection theory to advocate for cutting giant swaths of forest and firing the firewood to make giant fires. And the heated columns with smoke in them would establish sort of this pyrocumulus above the fire and cause it to rain. And he was going to try to get government grants to light these fires every Sunday afternoon after church, so that Monday would start out fresh and the rivers would be navigable. There's lots of stories like that, lots and lots of them. This is a book with, it's a history of science book with no heroes in it, just protagonists. Many of them were charlatans trying to delude, gullible people who would pay for rain, farmers and people at the state fairs. And some of it is full of scientists who were a little bit naive and had an idea about how they could intervene in nature, but took it to the limit for trying to control nature. So it's really not that hard to intervene in a cloud. If you have a propeller plane, you can pretty much tear up a cloud if you fly through it with your propellers, but you can't control it and tell it where it's supposed to go next or whether it's supposed to precipitate. The story goes through Irving Langmuir, the Nobel laureate, who his team at General Electric developed the use of silver iodide and dry ice. Nicholas Christophilus from the University of California had a project to detonate A bombs and H bombs in the upper atmosphere. It was immediately after James Van Allen had discovered the so-called Van Allen belts in 1958. And it was a case study of discovering something about nature and then immediately trying to disrupt it and doing it for military advantage. So there's a big story there about trying to make an EMP, electromagnetic pulse, or trying to disrupt communications through detonation of nuclear weapons. And one of the frightening stories is the doctrine. This is supported by all those little sort of Nike Ajax and Nike Hercules small rockets around cities in the 1960s that would take a nuclear weapon above a city and detonate it, because the doctrine was it's better to nuke yourself at high altitude than to have an enemy come through and nuke the surface of your city. They were trying to kill the pilots of the Bear bombers. They were trying to intercept incoming ICBMs. It was a very dark time. And so one of the consequences of this was the 1963 nuclear test ban after they had detonated a giant H-bomb in the magnetosphere, the Starfish prime shot. So I got onto this in 2006 when the meeting I was at, Lowell Wood was there. He's a great, huge, sort of a bear of a man. He was Edward Teller's protege. And he was talking about a planetary sunscreen with specialized design nanoparticles. And he was going to pump it into the stratosphere and let it go. It was the most dramatic conference I'd ever been in, because one of my colleagues, Alan Robach's a volcano specialist, and he was saying, well, it's a lot more complicated than that. You can't just make a nanoparticle and pump it up and spray it out and control the climate. And I remember Alan stood up at a very small table. There was probably 15 of us in a square table setting. And Alan stood up and got kind of heated about how complicated atmospheric science was and the reaction of the atmosphere to things like volcanic eruptions. And Lowell Wood stood up two seats down from me. And he stood up even taller than Alan. And he said, "Sit down, shut up. I'm right, you're wrong. It's all physics." And there was just such a heated conversation, so tense, so pointed, that it just became, the interchange just was burned into my mind. I was able to put some of that into the book. And so the book evolved from a very early classical hubris of controlling nature through the 19th and 20th centuries, kind of deluded and charlatan-like entrepreneurs and then into the current situation, which for me helped to show that some of the proposals are really quite similar to what had been going on beforehand. When somebody like Bill Gates tries to take out a patent on hurricane control, or there's other organizations trying to gain market share by cooling the climate through proprietary means, it meant a lot to me to have studied the history before that. Many of you might know Paul Crutzen, recently passed away this year. He was a very bright and very gregarious geoscientist, Earth system scientist, involved in nuclear winter and involved in all sorts of things, including geoengineering, ozone depletion as well. I can't forget that. And he wrote an editorial that said maybe firing sulfates into the stratosphere would cool the climate. And he called it a modest proposal in an editorial in Climatic Change. I didn't think he was completely serious. He might have been completely serious, but taking old naval guns and shooting sulfates into the tropical atmosphere was a kind of a wild idea. It was just about as wild as Jonathan Swift's solution to the Irish famine problem. And I once wrote a little essay about that, and it didn't go very far. But it seemed to be that his editorial never admitted that the something like the U.S. Navy should ask the people of the tropics if they should open fire on the stratosphere with military equipment from a past era, and whether those sulfates would stay in the tropics or would migrate all over the pole, all over the globes up to the poles, and maybe cause other sorts of unintended consequences. So I got a little philosophical by the end of the book, and I asked these Kantian questions about what do we know? And the answer is, we know something, but we don't know enough. We need better understanding of the atmosphere. What do we fear? And that goes back to my apprehensions of fearing a climate that's out of control, or a climate that's unsustainable, or a climate that kills us all. That's pretty much where we're getting to now. And then the big question: what should we do? How do we respond as responsible moral agents? So it was a really fun to write, and it's out there. I'm going to keep moving here because Vlad and I edited this volume called Klima, which comes from the Osiris series, 2011. And there we had a good time looking at climate as a cultural phenomenon, not just as an atmospheric science, but as the fabric of our lives and as the ways that people make their way through their everyday life. And I had a lot of fun with talking about the first 2 meters, where none of the weather shelters are located. They're located usually at or above 2 meters. And this layer is where the atmosphere interacts directly with us. And we experience it at a dining table or a conference table. That's the 1 meter level. And we experience when we stand together in groups and talk. That's the 2 meter level. And so we called it the human layer, where we express our opinions. Some of the opinions dissipate, others grow, just like atmospheric disturbances. Our futures and the future of the planet will be decided in this human layer. It's very much like Bruno Latour's critical zone. He kind of liked that idea when I shared it with him at a meeting. But it's the sphere of human affairs, the most influential layer of Earth's atmosphere. You could say that, stratospheric ozone, thunderstorms at high levels, winter storm, these are all important layers, but this layer in a more metaphorical way is where everything we've ever talked about or decided is happened. So I brought in a little picture of the critical layers here. At Yalta, we have Churchill, Roosevelt, and Stalin at the 1 meter level. There's no table there, but that's about 1 meter where they're chest high. And then there's supporters and behind and standing as the 2 meter level. This is what I mean by the human layer, the critical zone where major decisions are made. And you can go on and on. You can become a general historian of the critical zone, I think. Okay, penultimate Next, but not exactly last, is the book called Inventing Atmospheric Science. That goes from Wilhelm Bjerknes and his protege, Carl Rossby, through Harry Wexler, the director of research at the Weather Bureau, to our friend and colleague, the mathematician Ed Lorenz of chaos theory fame. And I called it trying to solve the Gordian knot of prevision, but ending up tying a new Gordian knot of chaos. And the book is really not just about theory, it's about technology, because if you think of the 20th century, it's the radio century, it's the aviation century, and at least up through the 60s, it was the nuclear testing century out in the atmosphere, nuclear war too. We used the bomb. And these were transformative general technologies that the atmospheric scientists used to make things like radar, radiosondes, aviation and rocketry probes, and even nuclear tracers. So I'm not going to talk much more about this, but the book ends, the book goes from 1900 to 1960. And when we get to 1960 and the launch of the TIROS satellite and the coming online of numerical weather prediction, boy, atmospheric scientists thought they just had it. They had this wonderful window into the future of the atmosphere, and it would eventually become really, really predictable. And just then, the emergence of chaos theory came at the same time. So the question that ends the book is, whither atmospheric science? How would you write a history of atmospheric science since 1960? Because we have the same technologies, we still have satellites, we still have computers, they're better than before. We don't have atmospheric nuclear testing, but we do have radiosondes and all the other communications devices and things like smartphones. So how would you write a history of atmospheric science in the last, say, 50 years, 60 years? And I'm running these slides. Here's an example of Marconi about 1900, opening up the radio age. The Weather Bureau in the US jumped on this technology right away. The Wright brothers with getting off the ground in 1903. Again, the atmospheric scientists began using aviation extensively. And then the bomb tests, and the bomb was not the destructive power of the bomb, but the indicative power of the nuclear tracers was of interest to them. Next slide is a better airplane. This is kind of Harry Wexler's World War II airplane that he flew into a hurricane. A radio sonde about 1936 that ushered in an electronic age for meteorology, where they had to have training in not just in the equations of atmospheric behavior, but they had to have electronics to trace the radio sonde going up through the atmosphere. And then the nuclear tracers, the lower left is a map of a Russian bomb test that was detected coming across the Pacific and across Canada. These are some of the technologies that transformed the atmosphere. And I have a little section, I call it shape-shifting noun. The atmosphere was just pretty much surface weather in 1900. It might include some mountain observations, some cloud observations, but by the 1930s, it included the middle atmosphere and the Rossby waves propagating at high altitudes. And then by the satellite era, it meant the whole envelope of the atmosphere looked down upon by satellites. And now it's pretty much atmosphere covers from the surface of the Earth to the surface of the sun. So that one term, atmosphere, has expanding meanings as the technology and the science allow it to expand. Again, one more slide to show all these three, no, and only two families now. The radio family includes radar. It includes the radio tubes in the ENIAC computer on the upper right. There's Johnny von Neumann, second from the left, with Harry Wexler next to him. Some other very important atmospheric scientists, Jule Charney on the far right. And then captured V2 rockets with a second stage. This is the bumper V2 taking a probe into the upper atmosphere to try to determine its temperature characteristics. And then 1960, the TIROS moment. So these technologies, I only picked three families of technology, but they are all interrelated families of radio, aviation, aerospace, and the nuclear tests. Ed Lorenz, what more can we say? Here he is in his kimono, in Japan, 1960, where he first gave a paper on the limits of prediction, the strange attractor known as the butterfly. And for those interested in history, Rossby's one of his best students was Bert Bolin, who became the chairman of the IPCC. And Bolin was the commentator on Lorentz's paper in 1960. And Lorentz said, well, there's a limit. There's a theoretical limit to predictability, at least in the models I'm working with. They were simple models. But Bolin said, really? You mean we really can't get beyond this? And Lorentz pretty much said, I'm paraphrasing, he says, yes, it's a hard theoretical limit to our ability to predict the future. So that's pretty deep, I think. I'm going to move on to First Woman. I thought I sort of told Vlad I'd like to talk about this book, but he said, no, give us the big picture, which I'm going to wrap up now really quickly. Joanne Simpson was the first woman to earn a PhD in meteorology from the US, but there were other women in meteorology. There were people gaining degrees under Wilhelm Bjerknes in the German universities. There were Norwegian women, and there was even British, not PhDs, but very high theoretically trained women before the 1940s. This is also Joanne's life story. She came from Cambridge, Mass., kind of had an abusive family, or at least her mother was pretty tough on her. And she went to the University of Chicago, where she met Rossby and specialized eventually specialized in tropical meteorology, working together with Herbert Reel. She was a pilot. She was trained in the aviation club at Chicago, had got her pilot's license back in Boston. And she went to Woods Hole, where she was able to fly into the tropical atmosphere. And by observing and carefully working in the tropics, she came up with her hot tower convection hypothesis and was able to intervene with some seeding of clouds and hurricane modification. I could have studied 3,000 tropical meteorologists that have written about 10 or 15,000 papers, but I decided to use Joanne's career as a gateway into the tropical atmosphere. The history of tropical meteorology is not well known, and this is a chance to put together her life story and the story of the tropics. The tropics turns out to be one of the most important parts of the general circulation of the atmosphere, and she had this idea that giant cumulonimbus clouds in the tropics are like the spark plugs of the general circulation. They're running the engine. They're pumping the heat and moisture upward and then eventually northward that runs the whole circulation of the planet. And that was an understudied area circa 1950. She flourished. There's a long story. The book is a lot about her own interior life, her challenges, her various loves of her life, and her limitations, her health limitations. But it ends on a high note, where she found her way in later life at NASA, where she became the chief scientist for the Tropical Rainfall Measuring Mission, the TRMM satellite launched jointly by NASA and the Japanese Space Agency. And TRMM was able to look down on the tropics. It was the first radar in space. Again, technology plays a big role. It's able to reveal the hot towers and the circulation of the tropics, which still today is one of the missing items in a lot of the general circulation models. We know a lot about the North. A lot of meteorology theory was developed by men from the North, centering around the polar front idea. And this book doesn't have those sorts of dimensions. It's about a woman in the tropics who went out to observe for herself and took extensive notes. And she also built the first digital convection model on the Swedish BESS computer. So usually when you think about computing in meteorology, you're thinking about the Institute for Advanced Study or the different models of atmospheric predictability. But she did a vertical two-dimensional model with convection at the core. It might have been one-dimensional, just in the vertical. Joanne Simpson is a highly admirable person. Her mentor, Rossby, didn't want to be her PhD supervisor, so he passed her off to Reel. and in a way, she scooped Rossby. Rossby didn't have the idea of the hot towers. He didn't know the dynamics of the tropics. He just had some big ideas, that wonderful ideas that he is duly famous for. But in a way, Joanne was able to scoop him as a young woman entering the field. And there's a lot of the stories in the book about the struggle she had. There's a hot tower surrounded by other kinds of convection, some cumulus congestus, and maybe 2 hot towers there. But this hot tower is producing its cirrus shield, and there's a lot of other smaller clouds around it. She used the metaphor of tropical trade cumulus I used it actually to try to symbolize all the women in meteorology that entered the field but never broke through to a high level because of that metaphorical tropical trade inversion. And so Joanne's colleagues were well-trained, very brilliant, hardworking, but were sort of capped in their careers. Joanne broke through and got to the top of her field and became the person who exemplified the hot towers that she studied. This is Trim's image from space, the first radar from space. This is actually a hurricane coming into the Philippines on top of Palau right now. And the red spikes are the intense convection that she would have deemed to be the hot tower convection. They're circling the eye of the hurricane. This satellite continued till 2015. Joanne passed away in 2010, but the satellite didn't splash down till 2015. And now there's a new satellite up there called the Global Precipitation Monitoring System, GPM, which is providing critical, both scientific understanding of the tropical atmosphere, and it's also pitched as humanitarian support for people in half the people of the world in half of the world's area in the tropics who are not as privileged as the people in the northern tier. And so this is both humanitarian and scientific satellite. So history matters. This is another one of my mottos. And I know you have Met matters and our Met SOC matters and stuff like that. And I think I've hoped I can continue this work. I'm trying to make the case that history matters. It matters a lot, not just for its own sake, but it matters for policy sakes. It matters for understanding science and for seeing that we are not the first people to think about this, not by a long shot, but in many cases, our distinguished predecessors took a good using the perspectives that they had, they provide a good foundation upon which to work. So if you're a scientist, history matters a lot. If you're a historian, history matters a lot. If you're just working on and interested in the field, I think it also matters a lot because it expands your horizon immensely. Thank you for your attention. I really appreciate the ability to be with you today.
Thank you very much, Jim. Lovely as always. I'm back now. I'm happy to take questions from the audience. My understanding they'll be showing up on the screen somewhere. I did see several of those in the chat box, and I can go back to them unless Eleanor or Julian tell me otherwise. Okay, here is the one. Very good. So, Jim, this comes from Hans Volkert.
Oh, Hans. Hi, Hans.
Hi. And this is the question. The atmosphere is a continuum broken up in boxes, that is scales by scientists. History appears to be similar. What are your thoughts, Jim, about a hierarchy encompassing broad brush large history studies, evolution of institutions, biographies of scientists as a kind of historical case studies?
That's great. Thanks for the question. I like the metaphor, the analogy to scale analysis. I don't think downscaling works too well, perhaps not with the climate models going local. But with history, the broad brush is important. You have to see the big picture, but I think you also need those very particular personal studies. I have I have never done a biography per se until I did the Joanne book. But the other books have little, not just little, but extensive biographical perspectives on the people and their motivations and why they were doing what they were doing. And in that case, I guess I was scaling up. I was starting with the early lives and inclinations of certain scientists. In Joanne's case, highly persecuted and suppressed by her larger society. And then I was working up to something like a hot tower in the general circulation and her ideas about it. So I think you have to work up, you have to work downstream, and I'm not sure it's exact metaphor with atmospheric science, but history is a complex field, and you have the best histories are the ones that you think you have the resources on hand, or you can get the resources to do them, and you have your own motivation to go ahead and go forward with it. But broad brush, often you see broad brush in the popular bookstores. It's derivative from other people's works, and it's effectively not so satisfying. The broad brush combined with detailed case studies and even micro history matters a lot to me. I hope that helps.
Okay, thank you, Jim, on behalf of Hans. Next question. Right, I think I'm getting something. I've seen a couple of those in the chat box, but I'm just waiting to have confirmation from Eleanor and Julian if they want to give me the next one. Okay, here is one from Sam. What history of meteorology / oceanography should we be studying that we haven't yet got around to?
Oh my, it's the collective we. It depends on who you're reading and how you're reading it, but I'm echoing now, right? Am I echoing?
You're fine.
Okay, good. I just got a notice from Mike Hume that he has written a book called Climate, and it's supposed to be part of a trilogy where or climate change, I think. He looks at climate, he looks at why we disagree about climate change, and now he's doing the whole analysis of climate. That is a big book. I think that's going to be a valuable contribution from him. Oceanography, the Commission on Oceanography is also very active. Again, looking at the small and the big and trying to orchestrate them in communication with one another. I am probably going to get in trouble now with a study that I'm trying to get off the ground that's only a running title called Big History and the Anthropocene, Critique and Counterproposal. And that's taking on a big issue, but I don't yet know. I don't have I don't have the vehicles in mind yet to do the counterproposal, to look at the details. But when I do, if and when I go after that kind of topic that is really huge, and it includes all of society and all people and all humanities and all kind of different perspectives on scientific studies of sustainability, I'm going to have to find vehicles to get there. And I think that goes back to Hans's question, that you can't get there from here. Well, they often say that in Maine because there's so many lakes in the way. But the way to get there is to make a detailed plan, whether you have to portage your canoe, or whether you have to walk a certain distance or take a roundabout route, and or whether the road's closed in winter. There's all kind of metaphors like that. And so I am foolishly or boldly working with some students this summer on the big issues surrounding the Anthropocene. And I will then be a lot more careful about trying to define which of the case studies is going to get me to my goal. So yeah, I don't know. I think the field is just about as semi-infinite as the atmosphere, and there's all kinds of studies to be done. It'd be great to see a careful study of Ed Lorentz's work and career. But and there are things coming out like that. But what I don't appreciate, I get a lot of traffic on derivative books, things that are put together mainly to sell books, and I'm not a big fan of that. I like books that open up new questions and new territory. Just email me and we'll scheme some of these things.
There's some activity in the chat box, but okay, there is the next one. This is coming from John Gould. Development of scientific ideas is critically dependent on the interaction of people who share ideas. Those interactions are rarely documented in the published literature. It's only by studying the history that those crucial personal interactions are revealed.
Yeah. I agree. And I would say that I'm also an archives buff. I love to get into an open archive. I didn't mention the Radcliffe Institute had Joanne's personal papers, and they're very, very detailed and very, very candid. Other great archives are extremely valuable when they have unfiltered correspondence, notebooks, journals. It's kind of like the calendar papers. When you can see over the shoulder or try to get into the mindset of the people you're studying, and you find out which associations they're involved in, who are their closest colleagues, how did those colleagues interact. But again, you have to make a doable finite study of that, because you can really get lost in the weeds with that. But I think it is crucial to document the personal interactions, also the social setting, also the bigger political, even military setting, the kind of the social history of the field, as well as its intellectual history.
Thank you. We have more questions I can see. Let's see what shows up. Next question. Okay, this one comes from Elena. I think it's really important one. We often hear the past is not the future in climate change context. What does history tell us about unprecedented climate changes we are seeing?
That's a real good question. It reminds me that I might not be able to answer every question. I think that unprecedented is an overused term. I remember back in 2006 it was, or maybe a little bit later, almost everything was unprecedented, which prompted me to think of my historical rejoinder. In some ways, the cutting edge of the present is something new. There are new things in the world. There is something new under the sun, as John McNeill would say. But there's also continuity as well as change. And so history tells us not to neglect the continuity and not to just leap onto the change as if you were suddenly discovering something for the first time. So I think what history tells us is that the challenges we're facing require all of our talents, and those people that can take the time and effort to study two or more fields, or to be more interdisciplinary and more international, and perhaps more intergenerational, will get new perspectives, and they'll have questions that they never thought they could ask. They never thought about them. So I was always a big proponent of the 3 I's, the international, intergenerational, and interdisciplinary. And I think having had the personal experience of studying atmospheric science was very good for my history, and vice versa. So I don't know a specific answer, but we're going to need, as Gro Harlem Brundtland said in the conference in '72, she said we need all of our talents to address these issues, and that's kind of what my approach to that.
Coming from Nigel, is there an increasing problem in history of climate with misinformation?
I, misinformation is a neologism, and I think it varies by your setting. It's a very big new term here in the U.S. with the blocking things by Twitter and Facebook and things like that. I don't know how it's playing out in the British Empire, but the UK, but I don't have the question in front of me, but I don't think so. I mean, there is a robust debate, but I don't think it should be totally polarized like it is. I don't agree with people that call each other names, whether they're warmists or deniers. And I think science proceeds by sincere and robust debate to try to, in some cases, to try to disprove certain hypotheses. So I don't see it as a problem. I see the bigger problem in the bigger culture as trying to shut down debate and trying to shut down any discussion of a variety of ideas. So that's where I come down on that.
Right. Thanks for that. There's one that's about the operational weather forecasting. The question about who's written the history or histories of operational weather forecasting, Jim, apart from usual suspects, which Christine, Nebeker, Paul Edwards has done some work on that.
Yeah, glad. I think you're answering the question quite well. I was in a meeting in, I think it was 2004. It was the 50th anniversary of ONWP, at least from the American point of view. And they date 1954 as their first useful forecast. At that meeting, I saw a contrast between a large school that said, give us a big computer and lots of core computing time, and we're going to solve these problems by adding more and more routines. And a smaller group that was more on the side of the chaotic limit. And so I think there's still room for a critical history of operational weather forecasting. So, some of the directors of the Weather Service who were involved in that, George Cressman and people like that, tried to do and Joe Smagorinsky, they tried to do their personal memoirs on this. And certainly Christine and Rick Nebeker and to extent Paul Edwards were very good at this. And of course, I took a little shot at that when I talked about Vladimir Zworykin in the RCA scientist of the 1940s, who convinced Johnny von Neumann that weather prediction by computer would be the starting point of weather control, that the computing would be so accurate that we could intervene in the weather systems as they develop. So I think there's still room for some pretty interesting contributions to this field. And as I said, Joanne herself made a digital cloud model or convection model, which was not about forecasting the weather. So I think there's still room for creative contributions there.
Thanks. Now, okay, we have, do we want to go to the last question from Tess? I think it's interesting because it has elements of the introduction in it. And this question is, you've got degrees in science and humanities. Do you think that kind of formal training, that kind of formal training in different disciplines is necessary for people wanting to do history of science?
No, a lot of historians of science don't have science degrees. They might have degrees in other things like anthropology, sociology. They might be coming through a different channel. But when I went to grad school, one of the admissions requirements I was told later was that the candidates had to have done something notable in history or in science. And my university then was able to supplement my lack of training in history, but I could build on my training in science. So I remember my first project was a Darwin seminar. It was about Darwin's Origin of Species and the aftermath. And when we were having the seminar, this was in the 1980s, a concordance to the Origin of Species came out. And it was kind of a curiosity piece because it was like the concordance to the Bible. I mean, what do? You look up key passages in Darwin. But I decided that what I would do is look at his earlier work on the essay and sketch of 1842-44. And I knew how to run a computer, so I digitized the early sketch and essay and ran a computer concordance with that. I mean, I could move cloud particles around. Why not move words around? And so I published these things. I sold a couple copies to Darwin scholars, and then I wrote a paper for my graduate seminar on Darwin's delay and Darwin's development that showed changes in his linguistic strategies in the course of 15 years. And so in that case, the science training supported my entry into historical training. But I did in the historical training, especially historiography and being part of a large network of professional historians of science, really benefited. I was really happy to be able to be trained and to try to raise my sites and standards and not make certain claims like now we know and the father of this and the father of that. I think I avoided a lot of common errors that might not occur to people without the training. So I'm a big advocate of getting your graduate degrees, but that's just like I said, this talk is mostly autobiographical, so I can't generalize and say what others should do. And it's late in England. It's only 4:17 here in the beautiful afternoon in Maine. You guys are hanging in there, asking questions. This is really exciting. I wish I could be with you. I wish we could go to the pub now, right afterwards.
Yeah, we wish. Yes, thank you, Jim. One more time, just clap for me on behalf of everyone.
Well, here's to everyone here. Here's to you folks.
Fantastic. I want again to thank you for the great talk. But before we conclude, I just wanted to say a couple of things. That this talk, as other talks, will be published on YouTube and Ermat's website. Here are the links. If you want to keep in touch on Twitter, on Facebook, direct by email, here are the links. And finally, a couple of announcements about two things. One is the virtual meetings on atmospheric sciences for solution, which takes place on these 3 dates up here. And there is a program here on that URL underneath. But next year, next 12th of March 2022, there is an in-person, we hope, meeting in London on the history of climate science ideas and their applications. There is program out there already, and you can go and check that on that link underneath. So I want to thank again. Jim, is there anything else you wanted to add?
No, I'm just seeing that next meeting. I'd like to come to London.
Yeah, absolutely. You're welcome. Absolutely. So thank you all.
Everywhere.
Thank you all. Thank you, Jim. And thanks to Eleanor and Julian for making this possible from technology side. And I am going to sign off now soon, I suppose. I don't know if there's anything I need to do. But Eleanor will be probably in charge of closing this session. Okay, best regards, everybody.